Aromatic aldehydes, ketones, and quinones. Properties of benzaldehyde. Leave a few drops of benzaldehyde and watch a glass exposed to the air for a few days. Grind a pinch of starch with a few cubic centimeters of cold water and pour the mixture into about 5-10 centiliters of boiling water. Cool and dissolve in the solution a crystal of potassium iodine. Divide the solution into two portions. Shake one of those with 2 drops of benzaldehyde and expose both to sunlight for some time. Explain. Test for the aldehyde group in benzaldehyde. Shake up a few drops of benzaldehyde with about 15 centiliters of water and test parts of the solution with a feed solution, tones reagents, and shift reagents. Compare the result with those obtained with acetaldehyde. For the test with phenylhydrazine, see experiment below. If this experiment has not been performed, do it now. Benzaldehyde and sodium hydrogen sulfate. Shake about 1 centiliter of benzaldehyde with 5 centiliters of a saturated solution of sodium hydrogen sulfite. Filter off the crystals by suction and wash them with electrical alcohol until odorless. Dissolve the crystals in warm water to 1/2 of the sodium solution. Add a solution of sodium carbonate and to the other dilute sulfuric acid. Explain the cause of the appearance and odor produced. Shake up a few drops of benzaldehyde with a solution of sodium hydroxide and then warm the mixture. It is a resin formed, yes, compare that with those obtained in the case of acetaldehyde. And for the behavior of benzaldehyde with alkalis, see experiment 193, page 165. Benzaldehyde and ammonia hydrobenzamide mixed together 3 centiliters of benzaldehyde, 20 centiliters of alcohol, and 10 centiliters of a concentrated solution of ammonia set aside the mixture until the product with the separator becomes solid. Heat on the steam bath and add alcohol until the solid dissolves. Set aside to crystallize. Determine the melting point of the crystals. Compare the behavior of formaldehyde, acetaldehyde, and benzaldehyde with ammonia. Hydrobenzamide crystallized from alcohol in octahedral with melt at 110 degrees. Preparation of benzophenone. In a dry 500 centiliters flask, put 28 grams of benzene, 13 grams of anhydrous aluminum chloride in the form of lumps, and 27 grams of benzoyl chloride. The aluminum chloride should not be exposed to the air any longer than necessary, as it rapidly absorbs moisture. Attached to the flask by means of a cork and a small drying tube containing anhydrous calcium chloride. Place the flask under a hood in a beaker containing water and let the reaction proceed for at least 24 hours. Determine whether resection is complete. Pour a few drops of the material into a few cubic centimeters of water in a test tube. Shake the tube and observe whether the characteristic odor of benzoyl chloride is present. If the chloride is present, the mixture should stand for several hours and then be tested again. When benzoyl chloride can no longer be recognized by its odor, pour into the flask a mixture of 200 centiliters of water, 100 grams shaved ice or snow, and 5 centiliters of concentrated hydrochloric acid. Shake under running water until 2 layers are formed. Add the 15 centiliters of benzene and separate the solution from the acid. Shake the former with a solution of sodium hydroxide to remove any benzoic acid that may be present. Dry the solution with calcium chloride and filter it into a distilling flask provided with a thermometer. Distill using a water condenser until the temperature of the vapor reaches 215 degrees. Replace the water condenser by an air condenser and collect a weighted 200 centiliters. Back the material boiling between 285 degrees and 305 degrees. Record the weight of the distillate, which should change to a mass of crystal. Dissolve it in warm alcohol, 5 centiliters for each gram of benzophenone, and add to the cooled solution cold water until a permanent cloud is formed. The volume of the water used should be about 1/3 of the alcohol. After standing overnight, filter off the crystals and add water to filter as before. Wait The two groups of crystal calculate the yield and determine the melting point of the crystal. Benzophenone melts at 14.8 degrees and the boil at 306.1 degrees. The yield in the preparation is about 25 grams. Preparation of phenonexium in a flask provided with a reflux condenses of 5 grams of benzophenone in 15 centiliters of alcohol and add a solution of 5 grams of hydroxylamine hydrochloride in 15 centiliters of water. This had a solution of 10 grams of sodium hydroxide in 15 centiliters of water and heat the mixture on a water bath for an hour. Pour the product into about 200 centiliters of water, filter if necessary, and add to the filter dilute sulfuric acid until the solution is just acidic to litmus paper. After an hour, filter off the benzophenone. Weigh the product when dry and calculate the percentage yield, which should be nearly theoretical. Recrystallize the oxime from about 25 centiliters of hot alcohol. Benzophenone melts at 114.1 degrees. Beckmann rearrangement of an oxime in a small flask. Dissolve 2 grams of benzophenone oxime in 13 centiliters of other ether dried over sodium and add slowly in small portions 3 grams of finely divided phosphorus pentachloride. At first it may be necessary to cool the solution. Toward the end of the reaction the mixture should be heated on the steam bath until the phosphorus pentachloride has dissolved. When this is taking place, pour the ethereal solution with vigorous stirring into 400 centiliters of cold water. Stir until solid has formed, and then filter it off by suction and wash with cold water. Crystallize the benzene from the smallest amount of boiling alcohol and determine the melting point of the dried crystals. Write equations for the reaction involved in the rearrangement. Benzene melts at 116 degrees. Preparation of quinone. Mix in a large beaker 215 centiliters of water, 15 centiliters of sulfuric acid, and 15 grams of sodium bichromate, or the equivalent weight of the same bichromate. When the salt is dissolved, set the beaker in cold water and cool the solution in 20 degrees. Mix in a beaker 115 centiliters of water and 10 grams of vanillin. Pour into the mixture with stirring 10 centiliters of pure concentrated sulfuric acid and cool the solution in 20 degrees. And add it steam vigorously in 4 portions to the solution of sodium bichromate. The beaker in which the reaction takes place should be surrounded by cold water, and temperature should be kept between 35 degrees and 45 degrees. About 6 to 8 minutes are required for the addition of the solution of almylate sulfate. When this has been completed, remove the beaker from the water and let it stand for about 15 minutes. Add the flask 300 centiliters of ether, running water ether, and shake the flask end for a few minutes in order to facilitate the separation of the ether into a distinct layer. Add to it 25 centiliters of acetone and give to the flask of gentle rotary motion. In a few minutes, decant off carefully as much of the ether as possible into a separate funnel. If some of the aqueous layer flows into the funnel, it can be separated. Draw off the ether solution, place it in a flask, and distill the ether off from a water solution. Place it in a flask and distill the ether off from a water bath throughout along the water jacketed condenser. Extract the solution of quinone once more with this, recover the ether and evaporate it off as before. Crystallize the residue of quinone from the smallest possible amount of boiling liquor or distill it with steam in the ordinary way, except that no water is put into a flask containing the quinone. Dry the crystals of quinone in a desiccator. The compound is volatile at room temperature, and if left exposed to the air for a number of hours, an appreciable quantity is lost. Quinone melts at 116 degrees. The yield in this preparation is 5 to 6 grams. Proportion of quinone, reduction of quinone, shake up crystals of quinone which 10 centiliters of water, note the odor and the color of the solution, add to 1 alpha of the solution of sodium hydrogen sulfide, to the other alpha add the diluted solution of potassium iodide, and a few drops of diluted hydrochloric acid. Dissolve a few crystals of quinone in 5 centiliters of carbon tetrachloride and add drop by drop a solution of bromine in carbon tetrachloride. Make a saturated solution of quinone in water and add to the solution drop by drop a strong aqueous solution of hydroquinone. Examine the tube after about 1 minute. If crystals have not formed, repeat using a more concentrated solution of hydroquinone and a solution of ferric chloride to a strong solution of hydroquinone, add an ammoniacal solution of citrate to an aqueous solution of hydroquinone. Preparation of anthraquinone in 215 centiliters round bottom flask provided with a reflux condenser. Place 5 grams of anthracene and 5 centiliters of glass acetic acid. Heat the liquid boiling over while it goes and add drop by drop from a separate funnel. Place in the upper end of the condensed solution made by dissolving 10 grams of chromic acid anhydride in 10 centiliters of water and then adding 25 grams of 25 centiliters of glass acetic acid. Boil the solution for 10 minutes after the oxidizing agent has been added and then allow the mixture to cool spontaneously to the temperature of the room. Finally cool under running water. Feed by suction. Wash the crystal twice with a mixture of 2 grams of water and 1 volume of glacial acetic acid using 20 centiliters of mixture each time. Finally wash twice with water and allow the crystals to dry in the air. Sublime a small amount of the dried anthraquinone and crystallize a little from boiling alcohol. Anthraquinone sublimes at about 215 degrees in yellow needles, which melts at 273 degrees. The yield in this preparation is 5 grams. Boil together for about half a minute. Trace up powdered anthraquinone with a little zinc dust and 10 centiliters of a solution of sodium hydroxide. Fill the solution and shake it with the air. Anthraquinone is partly reduced by zinc and sodium hydroxide to a red salt of the composition. This salt is oxidized by air to anthraquinone. Reaction is available one in the identification of this substance. Compare the properties of anthraquinone with those of benzalquinone. Does the former oxidize an acidified solution of potassium iodide? It reduces by sulfuric acid. Note that after oxidation by chromic acid in acetic acid solution, the product is usually precipitated by pouring the solution into water. In the case of anthraquinone, it is convenient to allow the mixture to cool as the compound crystallizes well from glacial acetic acid. And that was the aromatic aldehyde, ketones and quinones chapter.